Hello, everybody. Thanks for being here late on a Friday. Hope I'm not too much of a letdown from Victor, and I hope he feels better. Um, so I want to go through this talk for you today, but first, before I do that, I want to say I've had the privilege of being at a lot of DevOps days. And please give a round of applause to the folks here. They did a really good job for first year, especially. So thank you. Okay, so moving right along, people have probably seen this saying. Werner Vogels is the Chief Technology Officer for Amazon, and he said this in 2006, that long ago. You build it, you run it. So if you build a service, you're responsible for running that service. And a lot of people in the years since have taken that to mean they wanted to get rid of operations costs or overheads or what have you. And in fact, that's not at all why he said it. The entire article, if you read it, it's on InfoQ. There's a link there. What he really points out is that they did it to get development teams or product teams closer to the customers. They wanted to get a feedback loop. They wanted to know that when they changed something, that sales would go up or down, or subscriptions would go up or down, or what have you. So those of us who talk a lot about small teams and product teams and that kind of thing, this is why. It's not about cost savings or anything like that. It's really about putting us in closer contact with our customers so that we can make changes when we need to and address our business faster and so forth. So this talk, you only have to change one thing to do the DevOps, but there's a catch. It's everything. One of the few words I know in Spanish, todo. Yeah. And so it really, my point there, and yes, it's a joke, but also is that many of the things that are required to really get to where you probably want to be, they're interchanged. You can't just change one. There's levers that pull each other and so forth. So I'm going to go through a few today. The first one is, I think that everybody needs to define or redefine some of the words for your organization, and I'll go into all of these quite a bit more. If there really was only one thing, a lot of times it's organizational structure. So small teams, that kind of thing. You can do continuous delivery on just about any architecture. They do it on Hewlett-Packard printer firmware. Okay, so if you can do that, you can do it on anything. But modern architectures and technologies will make it easier. And then I'll talk about a little bit about continuous delivery to safely deploy on demand. Not just deploy on demand, but do it safely. So I want to talk about definitions. And I want to be clear here. I'm going to go through some things that I don't think is what the term DevOps means. And I'll warn you, if you're a DevOps engineer, I'm going to probably not make you very happy. But that's okay. And then I'm going to show you some definitions. The goal of doing this is not to try to convince you to adopt my definition. Okay, like Jessica gave one earlier that from Donovan Brown, that's very, very good. Dirk showed a few. The purpose of showing a definition here is so that you know what I mean when I say it for the rest of this talk, or if we're ever talking again. So you need to do the same thing inside your organization. You need to come up with what these things mean for you, and then print it out really big and put it on the wall. So that when somebody says, we're doing the functional tests, you know what that means. Or we're doing continuous delivery, you know what that means. Too often, those don't happen, and a team thinks something was done that wasn't just because they don't understand the meaning of the words. So what isn't DevOps? So the reason I do this slide, again, I was very lucky. I got involved with DevOps Days just about 9 years ago. So the first one in the United States. It wasn't the first one ever, but in your seat as an attendee and a participant and so forth. But at the same time, I was working on some of the earlier continuous delivery work at ThoughtWorks, where the book came out, almost 11 years ago now. And so I've been exposed to a lot of things. And the reason I do this slide is, again, it's more about clarification and understanding. So with respect to all my good friends at Microsoft, I don't think there's such thing as a DevOps tool. It's just too big. Okay, so if is it a monitoring tool? Is it continuous delivery? Is it continuous integration? Is it observability? Is it testing? Et cetera. And so I don't care for it when people say that they have a DevOps tool. I also, with apologies, I don't think it's a role or a team. when I get into my definition of DevOps, I think you'll at least understand why I think this. One of the things that I've found helps when I'm talking to people to understand how it's more of a culture and everybody working together is to think of it as verbs and not nouns. It's not developers and operators, okay? It's developing and operating. So developing includes security and compliance and experience design and all of those things. That's why purists like myself get, DevSecOps, DevBAOps, because it's developing, and so it already included security. I'm sorry that they felt not included. I truly am sorry about that. That wasn't ever the mean. It's developing and operating. One of the earliest attempts at a definition was a gentleman by the name of John Willis, who's the one who brought DevOps Days to the States. And he wrote an article when he was working for Chef, at the time it was called Ops Code, where he described it as CAMs. So it's culture, and this is partially, the setting of your organization, but also things like empathy and sharing and so forth, although sharing's in here twice that way. Automation. A lot of people think this is what DevOps is. It's not. Measurement. You can't do continuous improvement. You can't know if you're getting better if you don't know where you are today. And then sharing, doing things like this. Some folks like to stick in lean in the middle and call it comms, which is, I have no problem with for sure. John Willis would say that he thinks the others imply lean, and that's why he didn't do it. But most of the unicorns, if you will, the really, really high performers, et cetera, are using flow type methods, value stream type methods. They're not really using iterative development in its traditional form. And so when I say DevOps, this is what I mean. And there's a link there where I break it down of why I say that. But no, it's a culture, okay? And this is why I personally don't like the term DevOps engineer, because a culture where people, regardless of title or background, engineer, doesn't really work, okay? So to me, DevOps is everybody working together to build a thing. Okay, I said already that if you really could only change one thing, in most of the organizations, I don't know if people are familiar with ThoughtWorks, but we're about, I think we just passed 7,000 people. We're globally, we're a custom software delivery consulting. We see a lot of organizations. And I think this is the one where I see the most, where it's the most gains can be had. So if anyone's done Agile training, I literally took this from a 15-year-old slide deck for Agile training and redid it. But you have your development teams, if you will. This says testing team, but call it security, compliance, whatever you want. And then the operations team. And of course, the walls in between. And so we often, when we're talking about continuously in DevOps, we talk about these walls as bit boundaries where packages have to cross and that kind of stuff. And of course, that's important. But more than that, it's the communication. It's the understanding of what we're doing and so forth. There's a thing called the State of DevOps report that I think has been mentioned several times today. And also the book Accelerate by the authors of the State of DevOps report that goes into the math that they use and the science behind it. One of the more interesting findings to me is that the correlation between quality and automated testing goes away completely if the tests are not written by the development team. If the automated tests are written by a separate team, an outsourced partner, what have you, the correlation to quality goes away completely. There's lots of theories. It could be because if the developers are the ones, or the development team is the people that are going to be paged if it goes down, the tests are going to be better. It could be understanding of the system, what have you, but the math bears it out, and it's striking. I like that the customer clicks to buy the thing. Compliance. We need to do more, the whole shift left. The product teams need to take more responsibility for this with automation and so forth, but they're never going to be experts in this. And then also security. Again, couldn't agree more with Jessica and others that have said security needs to be part of the CI pipeline the product team's doing as well, because there are lots of different tools. She went through some, Twistlock, SNCC, there's lots of them that are relatively easy. But security is still a skill set. There's still penetration testing, there's still those kinds of things. And so, we're not gonna get rid of those teams, I hope. Please don't, let me put it that way. So let's talk about how this goes to continuous delivery. So again, I like definitions, so before I talk about it, I want to show you this. There was a book, I think it's actually on the next slide, written by Jez Humble and Dave Farley in 2010 called Continuous Delivery. They created the term. That's Jez's definition. To me, what I really like about this is the fact that it says all types. So it's the experiments, it's the configuration changes, and so forth. It's way easier to bring an application down with configuration changes than source code. Okay, so it's everything. But also the end part, safely and quickly in a sustainable way. I hear people saying, I have a pipeline I can get from code to production in 4 minutes. Like, yeah, that's probably not good. Because you're probably not running all the tests you should be running. You know, there are exceptions, but they're pretty rare. That's the book, more homework. This is the way I like to think of it. So I don't, the title of this talk is you can't do the or how to do the DevOps. You can't do DevOps. You can do continuous delivery, you can do automated testing, you can do observability. It's what you do as part of a culture. That said, there's a prerequisite, continuous integration. At ThoughtWorks, we have this thing called the radar where we look at different tools, processes, platforms, that kind of stuff. And it's not meant to be like an analyst paper. It's a statement of fact, meaning that if you ever download the radar, there's rings, and if something's in adopt, that means that we have adopted it. You could take that as a reason that you might want to look at it, but it doesn't mean that we're telling you you should necessarily. If something's in trial, that means we are trying it. There's things that sometimes have been out for a long time and everyone's really happy with them, and we put it in trial, and they're like, what are you talking about? This is stable. I'm like, yeah, but we haven't used it yet. Okay? One of the things that came up with the CI theater, the illusion of practicing CI. That made us do another small study, very, very unscientific, and I hated this. We asked a bunch of people, are you doing continuous integration? They said yes. Then we asked them a bunch of questions about their practices. Only 10% of the people thought it was different than just getting a tool. You know, downloading Jenkins, getting Azure DevOps, whatever it is, there are practices. It's not just that you're running a thing. And so it's funny because the people that wrote this continuous integration certification test, Martin Fowler and Jez Humble, despise the word certification, but so they did it as kind of a joke. But this is what we think of when we say it's CI. Every developer is committing to a shared mainline at least once a day. So trunk-based development. Okay? If you have a branch that lives longer than a day, you are not doing continuous integration. Okay? You're not evil, you're not a bad person, you might be doing really good build, automated, and test, okay, but you're not doing CI. Every commit does every test. And if the build and test or build or test fails, it's repaired. They said within 10 minutes. That might be a little aggressive. But the point is it's okay that the build server goes red. That's its job. But we don't leave it red. If you have flaky tests, quarantine them or delete them. Okay, because how often do we see where, oh, we know that one always fails, and that's because this or that or the other thing. And then something else failed and you don't know it, and it gets to production, and now you have 3 weeks of code to go through. So please don't keep flaky tests around. I love putting this slide in because I created a version of it for a sales call with Jez in 2009. But this is what a pipeline is. So it goes to, if it fails, it goes red, we fix it immediately. It goes a little bit further, if it fails, it goes red, we fix it immediately. And eventually it makes it all the way through. Now at this point, I do like to clarify the difference between two terms that are often interchanged and should not be. Based on the answers, people raising their hands and stuff to questions during the day, I think everyone here has probably got this. But continuous delivery versus continuous deployment. There is one difference between these things, and it's down there. Continuous delivery means that your software can be deployed at any time. Any time. Somebody can walk up to a system, given the right permissions, click a button, and it goes to production. Continuous deployment is nobody clicks a button, it goes. The level of rigor should be the same on both. A lot of people think that continuous delivery doesn't require as much testing or verification or whatever. Yes, it does, because someone's going to click the button. Okay? It's a business model change. So if you're a software as a service and you're rolling out small features and you're doing A/B testing like the travel agency and so forth, by all means. The magic of the internet, I was watching a talk for DevOps Days Guadalajara yesterday online. And somebody from Microsoft said they're deploying now 82,000 times a day. Cool. If you do that, if you work at Adobe and you do that with Photoshop, I'm going to get very angry with you. Because it doesn't make sense for that model, for people downloading on-prem software to have to update it all the time. So it's a business decision. So let's go back to our teams and talk about their role in continuous delivery. I truly want to give product teams, functional teams, whatever you want to call them, a path to production. They commit code. If everything passes, it's in production, customers can use it. This rightfully scares a lot of people. A lot of them wear compliance hats. But, I could very easily write a very bad application, put it on the public internet with ThoughtWorks logo on it, and ruin our reputation. That's bad. So that's why we say this. A lot of people, when continuous delivery came out, they just added a couple extra steps to the end and said, oops, CD. It's like, no, that's really wasn't the intent. The intent was to be more complete. Remember, safely, sustainable, all those neat words? Yeah. So examples of things which are bad. Deploying insecure software. Okay, who wants to get called on a Saturday night because you got hacked and 20 million credit card users, or your customers' credit card numbers got out? Anybody want to do that? No. Non-performant software. You can lose a lot of business with slow software. Non-compliance. And then the one not enough people test. Ineffective software. I rolled out a new feature. Did it meet my business goals? Did it create the value I was trying to create? Did sales go up or down? If I'm only deploying once a month and there's 19 different features in there, I have no idea which one made my business go up or down. That's why the smaller the changes, the easier it is to say cause and effect. If you take nothing else from this talk, this is probably the one. Okay, you cannot prove something is good. I can make a pipeline green just by putting a bunch of echo success things in there, right? You can prove something's bad. You can prove something has a known security vulnerability. You can prove something, is breaking a compliance rule, et cetera. But you can't prove it's good. So your pipeline needs to have enough tests and verification in it that you have full confidence that you can click the button and walk out the door. And so this is why I don't mind if a CD server goes red, because that's its job. Now you want to do local testing and stuff and not waste resources, okay? But when it goes red, you fix it. And in this day and age, with these complex distributed applications, you can't test everything locally. So you are going to break the build. That's okay. That's why the server's there. Just fix it. So let's go back to our pipeline. As I mentioned, and Jessica covered this, and I think Dirk covered this, we need security testing in there. I probably should make a box that says that. But we also can, and in many cases should, do other tests in parallel. I want to stress in parallel. Okay? So the security team or the compliance team has tests that they need to run before I can go to production. But I'm not in the development team's pipeline. Why? Let's say I put the security test between functional and deploy staging. If you need a staging environment, which a lot of people don't anymore because the way architectures work, if you want a staging, or if you have a staging environment, it's probably to test the deployment onto a production line. I always like to quote this because it's as old as I am, literally. It's 50 years old. It's called Conway's Law. And so I don't know if anyone else has put it up here already today. It comes up a lot at DevOps Days. But basically what this is saying is that if you have an organization that is developers over here and QA over here, your systems are going to end up reflecting that. Your pipelines are going to look like that. Everything's going to look like that. He was talking about physical systems like nuclear power plants at the time. But it really does happen. So what do we want to do? We want to change this. Now, if you look carefully where it says operations team, renaming that DevOps team does not work. Okay, it takes more than that. And this happens a lot. People are like, here's your Kubernetes book, you're now the DevOps team. Also, in most cases, having a separate DevOps team that's creating all the automation for everybody else is not effective. There are exceptions. I'm going to talk a lot about platforms later, and as a platform team and that kind of stuff, absolutely. But again, it's kind of like with the tests and the code. Somebody else automating, they don't know what my app looks like. And my app looks different than somebody else's app. So this is why so many people are really saying we want product teams. We want cross-functional teams that are responsible for a product from idea through retirement. Some people say idea through cha-ching. John Willis, I think, first said that. So idea through a customer using it. It's longer than that. It's till they're not using it anymore. Okay, so there's ownership there. So how do we do that? If we have a large monolithic system and that kind of stuff, that's hard. It's hard to have 10-person teams working on some of these systems. There are ways. But I want to be clear here that I'm not going to try to bash legacy. Okay? Legacy software is what pays most of us our salaries and what feeds our children. Okay? So let's be clear about that. That said, when it comes to this kind of thing, DevOps continuous delivery, monoliths can be very hard. I don't think it's going to be a surprise to anybody. So we had a customer, this has been, 9 or 10 years ago, travel industry, all the functionality in one process. The customer it was a massive C++ monolith. And of course, if they had to scale it, they had to scale the whole thing. So the travel industry got a lot of disruption in the last 10 or 15 years as hotel brands would come up with hotels would come up with new brands. There's Hilton, now there's Hampton and whatever, but they're all the same brand. Different specials, different airlines, bargain carriers, specials that are only good for a few days, that kind of thing. And they couldn't react, and they couldn't scale. When we first got there, we said, well, how often are you deploying? They said, about once a week. We're like, that's not bad. I mean, okay. I said, yeah, but it's the code freeze that was 6 months ago. And so the people were like, oh, once a week. Yeah, but it took them 6 months to react to anything. So they were getting killed. So what they wanted to do is decompose this. In this case, they chose microservices. I want to echo the author of a book I think you're probably going to see here in a minute, if I remember right. Microservices are not the answer to everything. In fact, they're the wrong place to start for a lot of things. I'm using this as an example, but because that's the client, but it's small pieces. Call it components, call it libraries, whatever works for you, call it features inside of a larger system. The idea is smaller pieces of work. But what they did with the microservices, of course, and this isn't going to be a surprise to anybody here, they took everything out as a separate service. Now they could distribute it and scale it as one. What this allowed them to do is go in and do, like, there's a special in Spain, they could scale that up and so forth. Holidays that are country specific or region specific, they can scale some things up without having to scale the whole monolith up. By some estimates, they didn't have an exact number, but by some estimates, they were able to reduce their data center size by 60% because they didn't have to scale the whole thing for stuff they didn't need. Now again, I care about definitions. So the term microservice was coined by two thought workers, Martin Fowler and James Lewis. I'm sorry, but that said, it was, and to us they mean something different. If you have two things that have a dependency, I have to deploy version 1.2 of this with version 1.3 of that, it's not a microservice. It might be a service, but it's not a microservice. If you have two things that use the same data source, it's not a microservice. Okay? Microservices must be independently deployable. So that means that, again, it's a product. So if I have version 1.2 and I want to make a breaking change to my APIs, I have to create version 1.3 and run them both in production in parallel. And then act like a product company, advertise to my consumers, hey, look at all the advantages you're going to get from 1.3, go change your system calls. I can't break them, but I can give them a deprecation schedule. I can say, I'm only going to leave that old version up for this period of time, whatever makes sense in your business. Please don't go rebuild your whole thing just because you can. Kubernetes is fun, it's cool, it's shiny, okay? But only do what you have to do. So in the case, again, of this travel company, what they did is they identified the services where they really knew the boundaries and would give them the most gain. So what are the things that they needed the most elasticity and those kinds of things? Build services where you need to react faster, which was their case, and where you need the scalability. I love this tweet. I hope you all can read it. And Jessica said a lot about this. Please don't chase complexity because it's cool, because I guarantee you're not going to be happy you did that when you get woken up in the middle of the night because your whole system's down. Okay, do what you need to do, but no more. So let's go back to our product teams. Now, for this travel agency, they can have these teams own certain services. And this has changed. Teams, of course, a lot of times own more than one, et cetera. But the point is it's owned. They know their business. They know how to do discovery. In this case, they got so good at it that they stopped doing requirements analysis completely. They didn't do like, oh, we have user stories, we have a hypothesis, and we're going to do a test with our customer and, whatever. If they had a hypothesis, they put it in code, put it on the website, Canary, A/B tested it. Did reservations go up? Yep, roll it out. Did they go down? Nope, take it out. It was faster to do that than to do the discovery. It was so successful that the VP of engineering was made the president of the company about 2 years later. So for those on a career path. Homework. And full disclosure, and it wasn't on purpose, but it worked out. I think all the books you're going to see are written by people that work or worked for us, so oops. Okay, that's it. We still have to deploy our software somewhere, right? I'm a big fan, and we've heard a little bit about this on some of the other talks, of platforms. I want to talk about a platform as a service specifically. So platform as a service, again, needs to act like a product. And the consumers are often the feature teams or value streams, or however you want to break them up, okay? So the platform team is providing a product to the rest of the company and building the features they need and not the features they don't, et cetera. So the example that I use for this is from the US, but it's an organization called cloud.gov. If you are a software organization inside the United States government and you want to deploy an application to the public cloud that's of certain risk levels and so forth, there are 325 security controls that you have to comply with. On average, it took a year to go through all the tests to make sure that everything could be done so they could be put on public cloud. So what the folks at cloud.gov did is they built a thing on top of Amazon's. Amazon has a government thing in the US that has some of this stuff. But they built a platform. And the platform ends up handling 269 of those. So all the things like, is your DNS properly configured? Do you only have the right ports open at the system level? All of that stuff is handled by cloud.gov. They have a thing called app packs, like Heroku, if you ever use that kind of thing. If you use those, then it's even better. But there's 41 that are shared, so they can't take full responsibility. And there's only 15 that are still full responsibility of the development team. So time to market has gone up by like, one of those, by like 80%. Because they don't longer have to spend a year in the testing, because the platform has already been verified to comply with these different rules. Okay, this won't be a surprise to anybody. There are actually computers. I fly a lot. I didn't see any computers up there. Okay, so we still have to do it. So we have our product teams. This scares some people. They're like, I don't want to be on a product team. I want to run Kubernetes. I want to be that person. I want to manage hardware. I want to do what have you. I think there needs to be product teams, but I don't think everybody can be on one or want to. So for example, that platform team, they are also a product team, okay, but they're not building the thing that's on the website like system. If I put the security tests in the middle and I'm waiting for somebody to approve something, I don't get to test that. I have to wait. But if I run them in parallel, then I can keep doing other things while those are running if those run a longer time. So think about like performance tests and soak tests, that those are running for hours. But I don't want to wait hours to get feedback from the rest of my pipeline. Now, the arrows in here, they have meaning. So the arrows that go up to the deployed production, that means I do have logic there in my pipeline. And a lot of the tools on the market now can do this natively. I do have logic there that says, oh, deploy staging was green? Okay, I need to run. Hey, security tests. Did you test this Git hash? Yeah, I did. Has it passed yet? Nope. Well, then I'm not going to run. Diamond dependencies, just like in programming. Okay, I can do these and run these in parallel. Again, I wish everybody could be on product teams. If you're in a startup, this probably doesn't apply. But in today's corporate world of corporate governance, this kind of thing is important. I was at a client here in Spain just on Wednesday, and they were talking about wanting to give product teams more autonomy. They wanted to allow them to run their own database so they could have a microservice architecture. But they are charged with governance for the organization on how are we storing user data, so GDPR and credit cards and all that kind of stuff. And so they're like, well, how do we verify? I want to give them autonomy, but at the same time, I don't want to go to jail. And this is one way that you can do that. So they can then meet with the product team during the inception, say, okay, what kinds of data are you going to do? Here's the compliance rules. Now I'm going to write a bunch of tests, and every time you build a thing, okay, let's call it a Docker container. So I build an image and put it on my repository. They're also watching it, and they pull it down and they run it through a bunch of compliance tests. It doesn't slow you down, but it also makes sure that you don't go to jail. Okay. Now all of this, there really is no silver bullet, and that's really kind of the point of the talk. There's not one thing you can change. You can't just create a pipeline or go get an automated test suite or what have you. These things are all interchanged, and there's a lot of dependencies between them. The other thing that come out of the book Accelerate that I like to quote is the change advisory board. So a lot of people have change advisory boards. So when in their survey, they said, okay, so no process at all, peer review, team process, or change advisory board effect on quality. Change advisory board was just a little bit worse than nothing at all. And the two in the middle won. So I apologize if that's your job, but change advisory boards in today's architecture and today's speed of movement have a negative impact on quality because we're not deploying fast enough and we're not getting fast enough feedback. So there's no silver bullet, but there is a lot of help. So I've already said some others, and these were not written by thought workers. Well, sorry. Yeah, okay. But I promise they're good. If you haven't read these, you really should. The statistics that I've been talking about are out of Accelerate, especially if you're in management. At your leisure, any time in the next day is fine. But you really should read that. So, summary. Again, I think definitions of words matter. Doesn't mean, again, don't necessarily adopt mine or Microsoft's or whoever's, but know that when your teams are talking to each other, that you know that you're talking about the same thing. Okay? The teams there's actually another book I didn't put a picture of in here called Projects to Products by Mick Kirsten. The move to small teams is a really important move to do this. Matter of fact, if you weren't in Dirk's talk today about trust as a foundation for DevOps, please watch it when the recording comes out, because he gives a lot of other reasons why small teams are effective. You can do CD on monoliths, you can do CD on printer firmware, but the modern architectures will help you. And then the point of CD, again, is safely. It's not about speed. That speed is a byproduct. You get the speed if you're safer. The speed and the risk actually go hand in hand. The faster you go, the lower the risk. So it works that way. And thank you. I know that was shorter than the time slot, but this is what I had prepared 3 hours ago. I don't know if we want to do questions or looking at the organizers.